What if a black hole were to suddenly appear above Earth? Its effects would depend on its size, mass, and proximity to the planet. Here's a breakdown of what would happen in different scenarios. Small black hole, micro black hole. Size and mass. A small black hole, with a mass less than that of a planet or even a star, would have an extremely tiny gravitational pull at a distance. If one appeared near Earth, it would not immediately pose a significant threat. Effect. The gravitational effects would be negligible unless the black hole were very close. It might only have a small influence on the Earth's orbit, and as long as it didn't get too close, the Earth would continue on its path around the Sun, unaffected. Stellar mass black hole. Several solar masses, size and mass. A black hole with a mass similar to or greater than our Sun. A stellar mass black hole would have a significantly stronger gravitational pull. If it appeared relatively close to Earth, but still far enough away to avoid immediate destruction, its gravitational effects would become more pronounced. Effect. The black hole's gravity could begin to disturb the orbits of planets, including Earth. Over time, it might cause the planet's orbit to destabilize, potentially pulling Earth toward it. However, if it were far enough away, say, within the distance of the Earth-Sun system, it could disrupt the orbits of nearby celestial bodies, creating a chaotic gravitational environment. Supermassive black hole size and mass. Supermassive black holes are typically found at the centers of galaxies and can have millions or even billions of times the mass of the Sun. If such a black hole appeared above Earth, assuming some kind of hypothetical mechanism for its appearance, its gravitational influence would be overwhelming. Effect. A supermassive black hole would have an enormous gravitational pull, likely causing the Earth to be drawn toward it in a matter of days or weeks. This would result in orbital disruption. The Earth's orbit around the Sun would be immediately disturbed. The black hole could cause a drastic change in the Earth's trajectory, eventually pulling the planet directly toward it. Spaghettification. As Earth moved closer to the black hole, the tidal forces would become increasingly stronger. If the planet reached the event horizon, the point of no return, the gravitational difference between the near and far sides of the Earth would stretch it out into a thin, elongated shape in a process called spaghettification. Final destruction. Once the Earth passed the event horizon, there would be no escape, and the planet would be consumed by the black hole, ultimately being crushed and compressed into a singularity, the point at the center of the black hole where the laws of physics as we know them break down. General effects of a black hole's gravitational field: time distortion. Black holes warp space-time, meaning that time near a black hole slows down relative to far-off observers. If you were observing the black hole from Earth, you would notice time passing at a different rate as you approached it. Accretion disk. If the black hole were pulling in matter, such as gas, dust, or even parts of the Earth, it could form an accretion disk around it. This disk would generate immense heat, potentially emitting X-rays and other radiation, making the region around the black hole extremely dangerous. Conclusion: if a black hole were to suddenly appear above Earth, the planet would be in grave danger, especially if it were a larger black hole. The gravitational forces could destabilize Earth's orbit, and as the planet was drawn toward the black hole, it would eventually be destroyed by tidal forces and consumed by the black hole's singularity. However, the likelihood of a black hole spontaneously appearing above Earth is extremely low. Black holes typically form from the collapse of massive stars, and there are no known processes in nature that would create a black hole in such close proximity to Earth. Hit like and follow. What if?